going to have a go at these 6 questions. Okay, refreshing revision, and do them in your book. You can do them in any order you want. Okay, I will give you a few minutes to get as many done as possible. Okay, go. Okay. All right, let's have a look at these. Okay, any one of these questions, anyone at all, pick one and let me know the answer. Delia.
Well, for 2, the one that you're having.
This one?
2, 18, 3, 12, 4, and 9.
Hold up, sorry. So one more time. 2 and 18.
Yeah.
Yep, what else?
And then 3 and 12.
3 times 12, good.
And then 4 and 9.
4 and 9, good. What else? Any others? You need to have them all. Eliza?
6 and 6.
6 and 6, right. What else? There's another couple, Liam?
1 and 36.
Yeah, don't forget the easiest ones, okay?
Yeah.
1 and 36. You have to have every single one of those numbers, including 6, okay, for all the factors. Put your hand up if you got all of the factors. Okay, good. Right. Okay, another question. Denham.
Circle 1.
Yes.
Circumference.
Okay, now the whole thing is a circumference.
Oh.
It says Chad.
You want the red part. It is not called Chad, okay?
You said name it.
Okay, you want the red part. Now, it's part of a circumference.
You said that.
You may not, but it's got a specific name. You may not know it.
Circumferential fraction.
No.
It's Chad.
1/4 of the circle.
No, it's got a special name beginning with A. It is called an arc.
Aaron.
Okay? If you didn't know it, no problem.
Aaron, good. Almost.
Oi. Okay, other questions? If you haven't answered one yet. Zaire.
A, the number sequence one, A is 11.
Okay, so the odd number?
Yeah.
Okay, let's have a look. So we want the 11th odd number. So the first odd number is,
Ooh, 21.
the next one is,
3,
the next one is,
5,
7.
7,
I got 21.
9.
Yeah,
Yeah, I got 21 too. I got
21.
21.
13,
13,
15,
15, 17,
19.
27.
What?
Sure.
all right. So we've got, let's count them up. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. Okay, so 21 is the 11th odd number. Anybody get any of these other ones?
Yeah.
Good. Ian.
For B, I may be wrong.
Okay.
Okay, I times 11 by 11, but that may be wrong. I got 121.
Right. Okay, that's absolutely right. What's the first square number?
1,
1, because 1 times 1 is 1. What's the second square number?
4.
Good. 2 times 2 is 4. So the 11th one, good one, Ian, is 11 times 11, which is 121. Good. What about the prime numbers?
I don't know.
Who can remember what a prime number is? Delia?
It's a number that can only be divided by itself in 1.
Good. It's a number that can only be divided by itself and not 1. So the first prime number is
Got 1.
not 1. Remember, 1 is a
3.
special case. 1 is not a prime number.
Oh.
The first prime number is 2.
Alright.
And then 3.
The next one is 3. What about 4?
No.
Because?
2
That's
and
2
1.
times 2.
Because 2 times 2 is 4. What's the next one after 4?
5,
Then?
7.
Then?
11.
9.
9 can be divided by?
2 times 3.
3. Okay, right. That's an easy mistake to make. So 11.
15.
13.
Keep going. 14.
No.
15?
No.
16.
No.
17.
Just guessing.
Let's stop guessing. 18.
No.
19.
Yes.
19, yes.
20.
No.
21.
No.
No. Yes, yes.
No, 7
No.
times 3.
Oh.
Yeah.
21 is not because
7
7 times 3 is 21. So 21
No.
is not.
23.
Not 22.
22.
No.
23.
Yup.
Let's count up 1, 2, 3, 4, 5, 6, 7, 8, 9. I need 2 more. What's after the next prime number after 23?
27.
27 can be divided by
It's 9.
Oh, 9 and 3.
9 and 3.
29. No. Yes.
29, good.
Yes, and then
31.
And then 31, right.
31.
Remember, there are numbers that can be only divided by themselves and 1. All right, good. Did anybody get all 3 of those?
Yeah.
I got 2.
Oh wait. No, sorry. No, not.
Okay, going back to the main questions then. Put your hands up. Give me some answers for these, Denham.
shape what?
Yep.
Base.
Come on. Right, go ahead.
Base times width.
For this one? No, we need to be. This is h here.
Isn't this like h squared?
And we want to find the volume of this shape. What type of shape is it?
Ooh.
It's
Wait,
a
I can't
Cylinder.
remember.
Cylinder.
Cylinder.
cylinder. Okay. Can anybody remember? Shh. The volume for the area of a cylinder.
Ooh.
No.
Height times radius.
Shh, gentlemen.
It's a unit for it.
Okay, this is a cylinder. It's also got another name, beginning with P.
Cylinder.
Prison.
It is a prism, right?
I thought it
Now, if I know what the area of the top of the shape is,
It's r squared, right?
it's not r squared.
It's r times pi.
Isn't
R
that
squared times
35?
pi.
Right, it's
Yeah.
pi times r squared. That's the
I mean,
area of the
that's
top.
part of it, yeah.
And if I want to work out the volume then of the whole shape, I have to multiply it all by
2.
h.
Oh.
So
I do
it's
that.
the area of the top, pi r squared, multiplied by h. Okay, that is
I didn't
the
even get
volume.
that.
Pi
from
r
answer.
squared.
I got you.
I got B times
That should have been
H
something we would have done
times
last
R
year.
squared.
Right, now this last one, without a calculator.
Wait, we haven't done the other one.
Well, this one, we'll
Can I
do this one in a
copy of
second.
it?
We'll do this one
I
first.
haven't done one yet.
I don't want to do it polygon.
Now, if I'm multiplying these two things together without a calculator,
Put the dot
Which-
in.
I'm going to leave the dots for a second. Well, I'll put them in actually. Which two numbers do I multiply together first?
9 times 5.
Right,
So you
5 nines are 45. Then what do I do, Zaire?
Carry the 4.
Yep,
9 times 2, 18.
uh-huh.
4.
Add the 4 is.
22.
Then somebody else, what do I do next, Delia?
You put a 0.
Good. Then what?
Then you do 3 times 5.
3
which is
5s
15.
are 15. Carry the
Then you
1.
have the 1
3
times 2
is 6. Add 1 is
You put
7.
the dot in and you add them together.
Yeah.
So I add them.
And then you get 11 dot.
I get
11,
975. Now, where do I put the decimal point? This is where people make mistakes.
Just bring it down.
You-
You
No,
do
that's
1
1
space
you
to
don't
1.
bring it down. How many places has the decimal point come in here? Once. And how many here?
1.
So that's a total of
2.
2. So I bring it in 1. So it ends up
I
in
did not
there.
know that.
It's 9.75. Right, the last one. 5 sides. Liam,
Yay. Okay, polygon. Or no, pentagon. sorry.
pentagon.
And then hexagon.
Okay, so we've got pentagon. 6 sides. Eliza, he's just told you. Hexagon.
Oh, I had that on my paper too.
And I'm pretty sure I
Septagon?
forgot the 7. Or
This-
the 7 one, but it
The
was
7
Isn't
sides
it heptagon?
is a heptagon. Good,
Heptagon.
Delia.
Yeah,
I
let's
don't
do
know.
it. We should
I
know
put
this from
seven.
science.
I was thinking
That's what I
French.
was using, but I was using science.
Yeah.
That's a big one.
All right, these are the facts. These are types of little facts that you should know and you should be aware of, okay? Shh. Now, the good thing with like this formula, for instance, this is given to you in the formula booklet, which is available on ManageBack. But factors, you need to be aware of how to work these out. You should all know what odd, square, and prime numbers are, okay? And you should all be able to do things like this without a calculator, okay? So, what I want us to do is we're going to start looking at sine and cosine curves. So this is what we're starting today. Now, this is still part of the same unit that we were working on, okay? Before the break. So we will do another assessment in this. So we're going to copy this down into your books, the sine and cosine curves, and including the 2 questions, okay? And we're going to work on this today by doing certain things. All good?
Okay. What do the graphs?
What are the graphs?
Yeah, we've got some bad English here, so I'm going to change this.
Yeah.
I do good English.
Mr.
English,
Constant
I
here.
do good English.
Let's
English
change
good
it
idea.
to what
I'm good.
do the graphs look like. Okay, so over the course of this lesson and the next one, we're going to answer these 2 questions. In order to do that, we need to actually figure out what both y equals sine x and y equals cos x look like visually, okay? Because they can be represented by a curve. Now, in order to do that, you guys are going to do it for yourselves, okay? I'm not going to just show you. I'm going to give you out a sheet which looks like this. I can zoom out. And you're going to fill in the sheet, okay? Whoopsie-daisy. Let's put that back up. So, plot the graphs of trigonometric identities, sine, cosine. We're not going to worry about tangent, okay? So we're not going to worry about this one. We're just going to look at sine and cosine, cos, okay? Now, this, what symbol is this?
Theta.
Theta, right, good, okay? That is theta. And we're going to say that theta, the angle, is each of these in turn, okay? And what you have to do is work out what sine of each of these is. Now, you can do it with a calculator. You may know some of them off already. Can anybody tell me any one of these that they know? Grayson.
0 is 0.
Sine of 0 is 0.
Right?
Is he right?
Yeah.
He is actually correct, okay? I'll write that in, okay? Does anybody know one of these ones, perhaps?
Oh, we did.
Yes.
Yes, we did. What about sine of 30 or sine of 60? Delia.
Sine of 30 is half.
Okay, and how did you get
Is
that?
0.5. Because we used the triangle.
We used the triangle, okay? Can anybody remember the triangle that we used to get sine of 30?
30 at the bottom. What?
No, 60 at the bottom.
60 at the bottom,
30
And
on
then
the
30
top.
at the top.
30 at the top.
It's half.
What goes here?
Root 3.
Okay, we're getting the right numbers, but just all in the wrong place,
So,
okay?
1,
So 1 at the bottom,
and then root
2,
Root 3.
and then root 3. Now, root 2 is the other triangle, okay? Now, look, guys. Okay, I told you this before the break. These are triangles that you must remember, okay? You can do this all in the calculator, but you have to know these. So, let's look at sine of 30. Sine is what over what?
Over 8. Opposite over.
Opposite over
hypotenuse.
hypotenuse. So, yep, Delia is right. Sine of 30 is, you did say that, didn't you?
Right?
You did say sine of 30 is
Yeah,
1/2, okay?
Wait.
Looking at this, what's sine of 60?
Sine of 60 is root 3 over 2.
Yeah, opposite over hypotenuse, root 3 over 2. Now, when we do this, let me just zoom in a little bit, make this easier for me to write. I'll zoom out in a second. So, let me just wait. So sine of 60, we said was root 3 over 2. Now, for the sake of what we're going to do here in drawing this, we can put this into my calculator, which is root 3. And if I'm going to divide by 2, can I just do it like this?
No.
Is that correct? What I put in the
The
calculator?
closing bracket.
Yeah.
I need to close the bracket, right. I need to close first off this bracket, and then I can put in the dividing by 2. And I get 0.866. So that's 0.866. Now, also you can do it in your calculator just by going to sine of 60. And it should give you the same answer, okay? So what I want you to do, you're going to use your calculator to work out all these values. You can just do them as decimals, okay? And then what we will do is we are going to plot them on this type of graph. Okay? And we will get some kind of funky looking shape. Okay? Alright, so I'm just going to put in the decimal values in here.
And then why would be 87? 0.87 if you round correctly. The
Yes,
60.
that would be fine. So Delia said, could we round it to 0.87?
Oh, it's going
That's
down.
fine. Has anybody done sine of 90?
Yeah.
What do you get?
1.
Good, and then keep going, okay? And then do the same with cosine. Fill in the whole table and also have a go at answering the questions at the bottom. Okay, right. So for those of you that have finished, if you haven't finished, don't worry. Just to keep those of you that have finished something else to do. Let's just quickly go through the first one. Okay, we'll do cos shortly. Okay, what is sine of 120? Let's go round. Damon,
Sine of 120 is 0.86.
say again.
0.86.
0.86. So I'll round it to 0.87. Okay. Denim, next one. 0.5. Zaire, next one.
0.
Okay, good. Grayson, sine of 210.
Negative 0.5.
Negative 0.5. Delia, sine of 240.
Negative 0.87.
Okay, we seeing a pattern here?
Yes.
Good. Eliza, sine of 270. Shh.
Oh, and I'll use a calculator for
-1.
-1.
-1. Okay. Great. Ian, have you got sine of 300?
Yeah, negative point. Sorry, yeah, negative 0.87.
Good.
So I was close. About
Liam, sine of 330. 330.
-0.5.
Back to you, Damon, sine of 360. Good. Denim,
0.
Grayson.
Oh, 0.87.
Sorry, I just left you out there, Zaire.
Oh, very good.
How rude. All right. So we've got all our values, okay? We'll do the same with cosine and we'll answer these two questions shortly. But what you've got the sheet already, and what you're going to do is you're going to plot these values on your graph, okay? So this along the bottom is which one here on the table?
Cosine.
It is the, so the theta, this line represents this line here, because that is my degrees, okay? And this one represents the sine theta. So the first thing I can plot on here is
0.
0, 0. Okay, so I can plot 0, 0, which is right there. I can then plot 30, 0.5, okay? Now, what does each little one of these represent? If this is 90 here, what is each one? Yeah, 30. Good, Eliza. So, sorry, that should be 30 and then 60, yeah. Silly me. And we said the next one we were going to plot was 30, 0.5. So there's 30. Whereabouts is 0.5 on this?
Right
Oh,
halfway through.
Halfway.
Yeah, halfway through.
One.
What does each one of these lines represent?
1.
2.5.
Oh, sorry.
I mean 0.25.
Yep.
How many is there? So
Oh,
1,
it's
2,
five.
3, 4, 5. So each one of them
Oh,
represent. Right, 0.2. Okay, so that's our first point. Our second point, what was sine of 60? Going back to our table.
1.
0.86.
0.87. So roughly in about here. And then sine of 90.
1.
Okay, so plot all your points. Plot all of them.
Ooh.
And do not connect them together just yet, okay? All good?
Yeah.
We're not doing this full thing, right? Because it goes up to 540. You go up to 420.
Well, you can just keep going.
Yeah, I just signed up.
You can see, yeah, if you can spot the pattern. So if I put the rest in as well as you go, so I've got 0.87. Sine of 150.
No,
Point-
half.
0.5, yep. And then sine of 180. Sine of 210.
Negative.
Thank you, sir. 240, negative 0.087. 270 is 1. Okay, keeping it nice and neat, hopefully neater than me, because this is difficult to do it on this.
Okay, so it's just like a roller coaster.
What about you?
It is like a roller coaster. And what do you notice about it?
Goes up and down.
Yep, and
It's like a wave.
it's like a wave. Okay, that's the perfect way to describe it. Okay, so if I join these up now, when you join these up, you do not use a ruler. Okay. Now I'm gonna try and keep this nice and neat, but it should be a nice curvy line. Okay, I'll draw it on this and then I'll show you properly. So it's gonna go up through the. Oh, this is off. Oh, please, please. Oh, this is a mess. Okay, I can't watch. I can't do that. Okay, let me draw it on Desmos. I've got that open somewhere. It's this one. Okay, so if I draw it on here, y equals sine x, you should get a nice
Oh.
curvy line like what we've got. Okay.
Oh, this is what the extent people are doing.
Alright, so it starts at 0 like what we had. Now this one's slightly different because the units here are going up by 1, 2, 3. But at this point, what is this value in hours and degrees? It is... Like what is this in degrees on your graph?
Oh.
When it's at its highest? Yeah, this is 90 when it's at its highest. And then it goes back down. It's like the wave, like we said, but make it nice and smooth, okay? Yes?
Go back to your thing.
And I'll go back to mine now. And I'll try and draw it in again, but make it nice and smooth. Okay, I'll do it bit by bit. I'm not the best drawer at the best times, but this is just atrocious.
They all need to connect.
That's not bad.
Yeah, they all connect.
You
Oh.
missed 0.5 up at the top.
If any of your graphs look like this, I'm going to make you do it again, okay? It's just that it's really hard to draw.
Wait, do you?
He's on like a pad.
Oh,
You can't
you
even
said-
see.
Yeah, so I'm on the pad, so it's really difficult. But nice and smooth, okay? So, like, that's the type of thing we're after, alright? Like a wave, okay?
Is this
That's perfect. That looks really good. Okay. So if I just go back, we're looking this nice, smooth curve, okay?
there's a
That looks really good, yeah. So if I go back to mine again, there we
You
go.
have to make it like.
I
I
don't
think you did yours wrong.
Yeah.
All right, so the bell's going to go in 2 minutes. What I want you to do is, for tomorrow, I want both of these graphs done for sine and for cos. Okay, for this one as well. So you need to do the table for cos. Okay, and I want both of these drawn on these axes, okay? Now I've gone around and seen most of you have done this one really nice, and I want it drawn all the way to the very end, okay? So don't stop just because the table stops, okay? We can see that this repeats each time, yep? So finish it off at home, okay? Nice smooth curve for both sine and cos, okay? And we'll have another look at it again
That was
at
quick,
it
that
tomorrow.
was-
All good?
Yep.
Excellent.